Samsung is really striving to win over TSMC on the 3-nanometer process, but seems to have failed. What are Samsung's weak points in the race of 3-nanometer GAA production?
Samsung has a problem with their PDKs. So a PDK is a process design kit. It's what people use to design to different fabs. And how you evaluate a fab process is you download the PDK and then you match it to your design and see how the models and see how everything works out. Samsung has a history of bad PDKs, and that just doesn't give the customers the confidence or the trust that they're going to be successful in their design. So that is really the problem that Samsung has had in the past. They have some loyal customers, Qualcomm and NVIDIA and some other companies, IBM, but they really have suffered through these bad PDKs. Recently, just about everybody has switched to TSMC for 3-nanometer because of the PDK problem. And they're really not confident that Samsung is going to solve the gate-all-around complexities up front. Sometimes it takes a little bit of time, and Samsung really wants to be the first one out to do new technologies. And they suffer, the problems that the first person who tries this new technology. So Samsung has that experience, but that's their culture. They want to be the first. But companies like Qualcomm can't really risk that. They have to have confidence that they're going to get their wafers in a timely manner and are going to perform properly. So that's really the problem with Samsung. It's a cultural issue, and they want to be first. They want to be bleeding edge, as they say, but customers really can't risk that. But TSMC's PDKs, they're very stable. They're very trustworthy. So people know that their product is going to be successful. So that's really the big problem. Qualcomm has moved over to TSMC, and so has NVIDIA. They used to do different designs in different foundries. But for 3-nanometer, it's really only TSMC. And it's going to be their biggest node in the history of the company, in my opinion.
What about tools or GAA structure designs? How does Samsung's GAA structure differ from TSMC's besides the nomenclature?
The test we've seen is the 3-nanometer GAA from Samsung is not as good as TSMC FinFET 3-nanometer. So the density is not as good, the performance is not as good. And of course, we have this reliability issue where we really don't know how well that technology is going to be manufactured. So Samsung is going to be the first. And, I'm very honored that they're doing this. I mean, my hat is off to them, but TSMC can't do that because their customers are very high volume, Apple and such. And if you're late, that's going to be an economic catastrophe as well as a technology one. So that's how it's going. I think TSMC actually will delay their gate-all-around and really focus on enhancing their 3-nanometer. They've already talked about new 3-nanometer processes and new optimizations and new technologies. They have this thing called FinFlex, where they're going to allow people to adjust the FinFETs to better their design. So TSMC really is pushing a lot on 3-nanometer, and they're going to own the node. They're going to have the majority. So I understand why they're doing that, but I think they're going to be very cautious on gate-all-around. And until it provides a significant benefit, both technology and economically, I don't think TSMC is really going to go forward with that process, until it's right and until Apple can use it and AMD can use it and Qualcomm and NVIDIA. So I think it's going to be a few years.
The gate-all-around technology actually has a reputation of bad yields. Which company do you think has a better shot in this matter?
I actually think Intel does. From what I'm told, I live here in Silicon Valley. I'm very active in the ecosystem. So I spend a lot of time with the IP companies and the EDA companies. When people ramp a process, they run all sorts of IP through it. They have SRAM, which is the memory that is embedded in a lot of this technology. I used to work for SRAM companies. I'm very deep in the SRAM community. So I hear things more than most. And from what I hear is that Intel is doing the best with the gate-all-around. So we'll have to see. But I think gate-all-around is going to be a new technology. It's going to be a new game. And there really will be a competitive battle between the three foundries. FinFETs is over. TSMC won the FinFET battle. They have the overall market share, but I think gate-all-around is going to be a new battle. Intel was the first one to FinFETs. They did hit some bumps, and I think that they were trying to do too much. Intel was trying to do these big nodes, and where TSMC does half nodes. So they do a half node or a new node every year, which really is optimizations, and it allows them to do yield learning. And it really is what allowed TSMC to pass Intel. So Intel stumbled trying to do really big steps. TSMC, did the half nodes, and now Intel is changed. They are doing half nodes, and so they're going to do 5 nodes in 4 years. No, 4 nodes in 5 years. What they're doing is the same TSMC steps, where they're doing smaller steps rather than large ones and stumbling. So I think that they did have some issues, but I think those have been resolved. So I have high hopes.